Well, g'day, Max here again, welcome back to the shop. So, if you watched the last video, you would have noticed that we were starting to play around with our horizontal boring machine here at Graffenstaden. So I thought I'd better pull my finger out and make this part one in the episode of the restoration of the boring machine that we have here. So, we'll swing you around. We'll have a bit of an overview of the machine and then we'll catch up to where I'm at with it and discuss our plan of attack. So what we have here is a Graffenstaden horizontal boring machine made in 1956 in northern France. So it's in a pretty sad old state. As you can see. When I purchased the machine, I purchased it at an auction and I was bidding against a scrap metal dealer, so hence this thing was destined for the scrap yard. I figured the machine was worth saving, as the price I paid was quite, was reasonable for it, considering the cost of buying horizontal boring machines here in Australia. So some basic dimensions on the machine. The table size is 800 millimeters by 1 meter. It's a full powered rotating table. The cross travel on the table, I haven't measured it, but it appears to be approximately 800 millimeters ish. So from the center of the table to the front face of the facing chuck is 2 meters. And if we have a look at the vertical travel, it's at the bottom of its vertical travel at the moment. So there's 800 millimeters of vertical travel. They do tend to take up a lot of real estate, as there's a fair whack sticks out the rear of the machine to accommodate the boring spindle that sticks out. So it has a number 5 Morse taper in the boring spindle, and the facing chuck is 17 and a half inches. What's that in our language? Which is it's about approximately 450 millimeters. The weight of the machine, it's quite a heavy machine. I'll take you off the stand here for a sec. I suspect this thing weighs in probably just over the other side of 6 tonne at least. The truck driver said it was quite heavy. The weighs on the machine are quite substantial. So what have we got here? 185 millimeters, bit over 7 inches. That's on the main casting there, and the cross slideways, 165 millimeters. So she's a pretty substantial bit of equipment to have in the shop, but it does need a full strip down to bring it back into a fully serviceable condition. It does have screw cutting capabilities if you ever feel the need to screw cut on one of these things. I'm sure not many do. So the facing chuck has just shy of 180 millimeters of cross travel, 7 inches. It can be fed across under power for facing operations or by means of manual crank here. And of course you can also mount a tool block on the slides here and mount a boring bar. the spindle has a good travel range. That comes out approximately 500 or 600 millimeters. So buried under this pile of boring bars and whatnot here, we have the tool support for the rear of the machine. So there is a drive shaft which connects this to the saddle of the machine. So as the main saddle goes up and down on the column, this tool support will also go up and down in synchronization with it. And so just there is the block that goes up and down. There's a little stub shaft sticking out of it at the moment for some reason. So yeah, spline shaft couples them together. With the machine also came this facing chuck. This is a 550mm diameter facing chuck, and quite rusty, but I'm going to strip this down and see if it's worthwhile reconditioning, and I'll move it on if it is. Also came with it was this other tool support off a much larger machine. So this is off an Italian boring mill. I'm pretty sure it's Italian. I do have the make written down, what it's actually off. I can't remember it offhand, but it's off quite a larger machine. So I'll clean this up and put this up for sale as well. But our main focus is on the one for our machine, which is this one here. So as I was saying, they do take up quite a bit of real estate. So this is the Spindle Assembly when it's fully retracted, and that's driven by an Acme threaded lead screw which runs down the bottom. Unfortunately, when the machine was loaded at the auction yard, they were a bit rough on it, and it did cop a bit of damage right here. So it's bent this shaft, so I've got to straighten that, and they snapped off the stud for one of the change gears here. So these are these are the change gears for the threading. So that's what happens. It's probably one of the very few times I've had a machine shifted and not been there to sort of oversee what's going on. So as far as the slideways on the machine, the cross travel ways are actually not that bad from what I can see at this stage. I've got a lot of cleaning up to do on the ways on the main casting, as I've already started, so that's what prompted me to start the video at the moment. So down the very end here, there was a fair bit of rust, but it seems to be cleaning up okay. There is, I'm in the middle of cleaning up this one, there is a bit of scoring on this way here, some pretty heavy damage. But when you look at the overall, I mean, it looks bad, but it does ride on the table does ride on a very large bearing area. So I'm fingers crossed confident there's not going to be any major issues that are going to affect the machine too much, but I won't know till I have all this removed as to the extent of the damage under there. But from what I can see so far, if that's the worst of it, we'll be fine. I mean, they're just grooves that hold a bit of extra oil, and there's nothing can be done about it. It is what it is. So we will have some interesting Acme threading coming up. There's the main lead screw here. If I look inside a bit further, I know it's got wear in it, I can feel it with the ridges on my fingers. So what we'll probably do here is we could recut this thread slightly undersized and then make up the new nut where it goes up inside. That's one option, but that's the sort of thing we'll deal with when we get to. This is the damage from transport when they crashed into it. So they broke this gear. So that's another gear I'll have to make. And yeah, the stud shaft they snapped off. So I think the back of the tilt tray hit it, backed into it. and it's missing should be a support comes up here to this shaft. That's something I'll have to make up, that's missing. So overall, yeah, it needs a lot of work. That's why it was destined for the machine tool graveyard. But like I mentioned before, it's the only way I will ever be in a position to get a HPM in this shop. So the entire machine is driven by this 10 horsepower, I think it is 7.5 kilowatt electric motor. Very old looking affair. The electrical cabinet. Yeah, this one came out with the arc. It's all it all looks pretty original in there though. So there's these big contactors. Remains to be seen what we actually do in here. There's a fair chance that a lot of it will have to be upgraded, as I don't know if this meets today's wiring standards and codes. We shall see. So here's a shot of the counterweight. Now this is attached via this chain to counter the weight of the entire saddle when it's raised up and down. Now I have a couple of bits of scrap bar running through the lockout hole at the moment, as a guy I know over the other side of the country, when he shifted his machine, the thing let go and the counterweight promptly disappeared inside the main column. So I still have to catch up with him and find out how he managed to retrieve it. So all the movements of the machine are controlled right here, just through the various handles and levers. All of the tags on the machine are actually in not bad condition. There is a couple I have to get redone. Has quite a reasonable spindle speed range, from 34 up to 1250 RPM. That's the spindle only, not the facing chuck. The plate or the facing chuck, that runs from 12 RPM, and that runs up to it's got 115 RPM here. Now I think you can couple the main spindle and the plate together, and you can run the plate a bit faster when they're coupled. So because there's a tag up here, not a very good shot of it. Faceplate not to exceed 300 RPM. So that tells me the pair can be coupled together just to get a bit more speed if you're facing. Has a good range of feeds on it, and it appears to have a lever here. Pull it across. It's for a quick return. Now I'm not sure if that's just for the boring spindle or not yet. So as I've never had the machine under power to run it. And the machine comes with a very old school digital readout, complete with its vernier scale, and runs the entire vertical travel of the machine. Now we have the table cranked back to the rearmost part of its travel, and now we can see the full extent of the condition of the slideways. They're not pretty, they're quite ugly, they're pretty sad. So what I'll do is I'll remove the lead screw and the feed shaft, which are laying in the middle there. I'll get them out of the equation. and I'll lift the whole table assembly complete, holus bolus, off the machine, and then we'll look at having a bit of a measure up and try and get a full assessment of what's going on here, and we'll come up with a plan to rectify any issues with to the best of our abilities with the equipment that we have here in the shop. So that's the major hurdle at the moment. If all that goes well and we can reduce, all we have to do is reduce the wear. If there's excessive wear, we don't have to take it all out, we've just got to reduce it. Remember, this machine has been around for a lot of years, so that's all we've got to do is reduce the wear. If we can safely or successfully accomplish that, then we'll tackle the other end of the machine. So you can see the area here where the table assembly's been sitting for a long time. So those zigzags are the oil ways underneath the table. So you can see we've got some pretty nasty scoring going on here. That's just a bit of corrosion. The zigzag, some pretty gnarly scoring going on here, and it's just in this area, well, mainly in this area here. The same goes for the opposite side. There's a few really gnarly spots in there. And of course the main drive lead screw, in this area here there's a lot of wear on it too. There is a feed shaft missing. I do have the other feed shaft which runs in this area here, and this is the feed shaft for the tool support. This is the feed shaft for the table assembly, and this is the lead screw for the table assembly. So a worst case scenario is we have to regrind the ways on this machine. So I have another machine which I was planning on regrinding the ways on anyway, so I do have to make up some of the tooling to be able to do that. The other thing is the underside of the table where it runs on the main ways. I know they're not flash, but the table, once it's stripped down, can be flipped on its back, and it's looking like it will just fit in the milling machine there, so we can remachine the underside of the table if we have to grind the bed. We'll see what happens when we check the condition of it, but we do have the capabilities to fit that table under that milling machine. The other lathe, this lathe here, was the one which is a future project. This is another one that has to happen. The ways on this do need grinding to bring it back to quite a good condition, which is what I want for this machine. It's another one I saved from the scrap, and yeah, this one will be going ahead. So we will have a lot of the tooling already made up to grind these machines, but we'll see what happens with that, but it'll be a big project to tackle, so it'll be an interesting one, so see how we go. Well, that's about where we're at with this machine. It is what it is. It was my really only option of being able to obtain a horizontal borer for the shop, so I've got to work with what I have here. So until we can make a full assessment of these ways, we won't come up with a plan of attack on how we're going to tackle it, but we will be tackling it. It will be happening, even if I've got to go to the extent of regrinding the ways to get the major part of the wear out of it. As I said before, we don't have to get it all out, but we've got to get some of it out. So anyway, so the next stage, yeah, we'll get rid of this table assembly. So we'll do all that in the next video. This video is just an introduction to the machine and where we're at and how we are going to tackle some of the problems. There's no problems, just solutions. So anyway, cheers. Next video we should be back onto the JFMT lathe because I need that done, up and running, so it's ready for when the wiring comes into the shop. So we'll tackle that one next. This project here will be a back burner project which I'll just work on from time to time, but I need the JFMT lathe going, that milling machine going, and my other equipment and my small shop shifted over and located here. So anyway, cheers, thanks for watching, and we'll hopefully see you in the next video.